students, welcome back to chemistry class. Today we are going to start a new lesson, that is carbon and its compounds. Okay, carbon and its compounds is the fourth lesson in your NCERT syllabus. Okay, this year organic chemistry, carbon means the compounds contains carbon. The branch is known as organic chemistry. Okay, organic chemistry is the one of the important chapter in your syllabus. Okay, coming to the organic chemistry in detail, so you have to know the sixth element. The sixth element, that is carbon. Where you can see carbon in nature? Everywhere, including your body. Also, carbon is present. Okay, when you talk about sugar, sugar is C6H12O6. It contains carbon. When you talk about any wooden furniture, the wood contains carbon. When you talk about the fuels, fuel contains methane, methane contains carbon. Since whatever organic components are present in your body, in your surroundings, whatever it is, carbon is one of the important element. Everywhere carbon is present. Okay, or the carbon can be present in different forms also. Right? We have discussed the different forms of carbon, that is graphite, diamond, etc. in the lower classes. The different forms of carbon. The charcoal is another pure form of carbon. Fullerene, etc. That you will discuss in this chapter in detail. Okay. Now let us go to the carbon, its atomic number, etc. Okay. Okay, students, let us discuss carbon and how the carbon has formed the compounds, etc. Okay. As we know that the carbon is the sixth element. Sixth element means atomic number of carbon is 6. Right? When you write the electronic configuration, how will you write the electronic configuration of carbon? Yes, the electronic configuration of carbon. K with 2 electrons, L shell with 4 electrons. Right? Yeah, this is electronic configuration. So 2, 4. This is the electronic configuration of carbon. Okay. When you look at the electronic configuration, can you say what is the valency and valence electrons? Yes. The valence electron is equal to 4. Valence electron is equal to 4 and the valency also 4. Right? Yes. So is the carbon stable? No. Because you know the octet rule. Right? What is octet rule? In order to attain the 8 electrons in the outermost shell, so either carbon should lose 4 electrons or it should accept 4 electrons. Right? The carbon requires 4 more electrons to complete the octet. Right? Yes. First, you can say that carbon either lose electron. When it lose electron, the carbon turns to C4+. Or in order to attain the stability, carbon should take electron. So when it take electron, it can be C4-. This is the two way to satisfy the valency. Okay, is it possible in order to attain the valency? Either it should lose the electron or it should accept the electron. Look at here, when you take the carbon as an individual element, center nucleus is there. Center nucleus, 2 electrons in the K shell and 4 electrons in the L shell. Look at here. Look at the atomic radius. Atomic radius means the shells are closer to the nucleus. The shells are closer to the nucleus means the atomic radius. The atomic radius is very small. Very small. So, atomic radius is small means nucleus have a high amount of attraction. Nucleus is highly attracted to each electron here. Okay. So, at a time you can see that the bonding, the attractive force between electrons, the negatively charged electrons and the nucleus is very strong. It is very difficult to lose the electrons from the outermost shell. Okay, since it is closer. So, losing 4 electrons is not possible. So losing 4 electron is not possible. Okay. And look at here. Is it any way to accept 4 electron? How will it accept electron? Look at the outermost shell with the 4 electron, right? Yes, outermost shell with the 4 electron. 4 electron. Look at here, already 4 electrons are there. So there should be a repulsive force between the electrons. Electron repulsive force is there. So again you are adding 4 electrons means the repulsive force is more. That time it lost the stability. So taking 4 electrons also not possible. So this also not possible. Then how carbon will attain the stability? Yes, I hope you have heard the term covalent bonding. Covalent bonding. What is covalent bonding? What is covalent bonding? The bond has been formed by the sharing of the electron. Right? If you have two elements, element A and element B, if it shares one electron, so this type of bond formation, a bond has been formed between these two elements. This type of bond is known as covalent bonding. So carbon also will involve covalent bonding with the last 4 electrons. So it cannot lose electron, it cannot accept electron. The final way is to involve covalent bonding. Let's check how it undergo covalent bonding. Okay. How many electrons? Yes, 4 electrons. 4 electrons means you can say that carbon is tetravalent. Carbon is tetravalent. Tetra means 4. 4 electrons in the outermost shell. Right? Yes. Look at here. Carbon, how many electrons in the outermost shell? 4 electrons. That you have to draw it in an electron dot structure. 4 electrons. So how does carbon get stability? Yes. Carbon will share its 4 electron with the other element. Other element will donate one electron. Okay. Who is capable to give 1 electron? Yes, just hydrogen. Hydrogen will give one electron, and 4 hydrogen will give one electron. So what happens? Already 4 electrons are there for carbon. So again it has been bonded with the 4 more hydrogen. Look at here. 2 plus 2. Total how many electron? 8 electron. Total how many covalent bonds? 1 bond, 2nd bond, 3rd bond and 4th bond. So 4 covalent bond has been formed. How many covalent bond? 4 covalent bond has been formed by the sharing of its electron. Okay, so generally you can write the structure CH, 1 bond. CH 2nd bond, CH 3rd bond and CH 4th bond. This name of this compound CH4 is known as methane. Name of this compound is known as methane. This is the first fully stable hydrocarbon. Okay, so hydrogen needs 1 more electron to complete the K shell. That is, carbon is ready to give 1 electron, ready to share 1 electron. Okay, and carbon already have 4 electron. Carbon require 4 more electron to complete the stability. For that it forms covalent bonds with the 4 hydrogen. Okay, this is the covalent bonding. Okay, so carbon is tetravalent. This is the first versatile nature of carbon. Carbon is a versatile element. It can have multiple amount of properties. Multiple properties are there. It may show multiple properties. The first, because it is tetravalent, so that it will undergo covalent bonding. Okay. Okay, students. What is the difference between covalent bonding and ionic bond? In the chapter 3, you have already learned ionic bond. Ionic bond. CD, covalent bond. What is the difference between these two? Can you say? Yes. Ionic bond has been formed by the complete transfer of electrons. Ionic bond has been formed by the complete transfer of electrons. But what about covalent bond? Covalent bond has been formed by the sharing of electrons. The third chapter you have learned many ionic compounds like what are they? Na2O, MgO, CaCl2, MgCl2, right? These compounds, this type compounds, one cation and anion. This type of compounds are the examples of ionic bond. And now you have written CH4, methane. It's an example of covalent bond because the CH4 bond has been formed. The CH4 bond has been formed by the sharing of electrons between carbon and hydrogen. These four bonds has been formed, right? This is the difference between ionic bond and a covalent bond. Okay. So using electron dot representation, you can represent many examples of covalent compounds. Let me tell you a first example of covalent compound. So H2. How H2 molecule has formed? You know that hydrogen have only one electron. This one hydrogen is not stable with one electron. That will definitely combine with the one more hydrogen with the one electron. So this will share this hydrogen and this hydrogen will share this electron. Totally 2 electrons form a single bond. Okay, so again covalent bond can be classified into 3. The first it is single bond, and the second it is double bond, and the third classification it is triple bond. This is a three classification of covalent bond. This is the first example of a single bond. The single bond has been formed by sharing 2 electrons. One pair of electrons has been changed. As a result, a single bond has been formed. If you take oxygen, what is the atomic number of oxygen? Oxygen with 8 electrons, right? Yes. So K is equal to 2, L is equal to 6. Look at the valence electron, 6. Take oxygen, first oxygen with the valence electron 6. 1, 2, 3, 4, 5, 6. This oxygen is not stable with 6 electrons. Definitely it will combine with one more oxygen. That oxygen also have 6 electrons in the outermost shell. This 6 electrons require 2 more electrons. So this will share 2 electrons. And the second oxygen will share next 2 electrons. Total how many electrons? 1, 2, 3, 4. 4 electrons are shared and 2 bonds are formed. Double bonds are formed. So between oxygen and oxygen, a double bond has been formed. Okay. And you will get that example of triple bond. How will you write the example of a triple bond compound? Look at nitrogen. Nitrogen with atomic number 7. Right? K is equal to 2, L is equal to 5. Take nitrogen and draw the 5 electron. 1, 2, 3, 4, 5. This one nitrogen is not stable. It will definitely combine with one more nitrogen with the 5 electron. Right? And this 5 electrons will share the 3 electrons. Then the octet is complete. And this 5 electron will share the next 3 electrons. Total how many electrons has been changed? 6 electrons. 6 electrons means 3 pairs. So the bond, triple bond has been formed. So the bond between nitrogen and nitrogen, it is triply bonded. Okay, and these are the examples of single bond, double bond and a triple bond. Okay,